Item I'm selling is our custom t-shirts, and it's going to cost me $12 to make each one with a startup cost to start the business of $1,000, but I can sell each t-shirt for $20. So the fixed cost, the starting cost, is always going to be $1,000 because that's what I'm starting with. I have to pay. And then the added cost is going to be $12 to make each t-shirt. So it's going to be 12 of 0 because I didn't make any sales yet. And that simplifies to 0. And then the total cost is going to be f of x plus a of x, so it's going to be 1,000 plus 12 of 0. And that simplifies to 1,000 plus 0, which is 1,000. So my total cost is still $1,000. Total revenue is going to be, I'm going to sell each t-shirt for $20. So 20 of 0, since I've made 0 sales, is 0. And then that final equation is going to be 20 of 0 minus 1,000 plus 12 of 0. And then that's all in parentheses, and that's going to equal 0 minus 1,000. So my total profit is going to be negative $1,000, which is what I started with. So after one sale, it's going to be 12 to the 1. It's going to be 12 to the 2. That's going to be 12. That's going to be 24. So the total cost is going to be 1,000 plus 12 of 1, which that simplifies to 1,000 plus 12, which is 1012. Same with this one. 1,000 plus 12 of 2 simplifies to 1,000 plus 24. 1,024 is going to be the cost. It costs to make 2 t-shirts, or it costs to make 1 t-shirt. Total revenue is going to be 20 of 1. This is going to be 20 of 2. So after selling 1 t-shirt, I'm going to make $20. And then selling 2 t-shirts, it's going to be $40. So that brings us to the actual profit now. So it's going to be the revenue subtracted by the cost. So it's going to be 20 of 1 minus, in parentheses, 1,000 plus 12 of 1. That's going to be 20 minus 1,000 plus 12, so 1,012, and that's going to equal negative 992. So I'm making $8 every t-shirt I sell until I eventually break even. This one is going to be 20 to the second, or not to the second, 20 times 2 minus 1,000 plus 12 to the second, and that's all in parentheses. That's going to be 40 minus 1,024 after you simplify. That's going to be negative 984. So I figured out that it's always going to be 1,000 for the fixed cost. The added cost is going to be 12x. So total cost would be 1,000 plus 12 of x because it's f of x plus a of x. The revenue is always going to be 20x because I sell each t-shirt for $20. And then the total is going to be revenue minus cost. So 20x minus 1,000 plus 12x. Okay, so here's number 2. I'm going to be graphing cost, revenue, and profit of this graph right here. So for cost, it's going to be negative 12x minus 1,000 because I'm spending $12 every t-shirt I make. And then I'm also spending $1,000 for the original business startup fee. Revenue is going to be 20x because I'm making $20 every t-shirt I sell. And then the total profit is going to be 20x minus 1,000 plus 12x in parentheses, and that is revenue minus cost. So I'm going to be showing the graphs on Desmos because I can't show all 3 and make them accurate if it's a y-intercept of negative 1,000 and they're going up by only 12. So I'll show you that right now. Okay, so here are my graphs. The total cost is going to be in red. It's negative 12x minus 1,000. As a y-intercept of 0, negative 1,000, because that's the original fee it costs me to start the business. And I'm spending $12 every time. So it's going to go right 1, down 12, and that's going to represent me actually spending the money to make the t-shirt. Right here in blue is going to be the total revenue. It has a y-intercept of 0 because I'm not spending any money to make to sell it, but that would be profit that gets counted in. So revenue is actually just money I make off selling the t-shirts. And then right here is going to be the total profit in green, and that also has a y-interception point of -1,000 because that's the original fee it cost me. And it goes up, and you can see right here 125.0 is going to be the x-intercept, and that represents the number of t-shirts I have to sell to break even, and I'll show you that on number 3. Here are those same graphs. In orange we have the cost, which is right here. Revenue we have in yellow, and then green is going to be the profit. Okay, so number 3 is to find the break-even point where the revenue and the cost are the same. So 20x equals 1,000 plus 12x. I'm going to subtract 12x from both sides. 8x equals 1,000 divided by 8. X equals 125. So I need to sell 125 shirts to break even from the original investment of. Number 4, with the data set I was given, it's data set 2. For temperature 1, I had -9, -3, and 6. Temperature 2, -46, -16, and 29, and then the difference between this row would be 37, 13, and 23. So I found out that the equation between 1 and 2 was really, it wasn't about adding and subtracting, it was about multiplying. So I found that temperature 2 is 5x minus 1 of temperature 1. So in like an example of that would be, this one would be 5x, so it would be 5 times -9 is -45, minus 1 would be -46. So that goes for all of them. And then the equation I found was actually x minus 5x minus 1 in parentheses. And that's all absolute valued equals the function of x. And that equals the temperature difference. So an example, so here is x, 5x minus 1, and that's going to equal the temperature difference. So an example of that, we could use this one right here. -3 minus 5, -3 minus 1, all in absolute value is equal to temperature difference. So this would equal -16, -3 minus -16, and the temperature difference is 13, and that's right there. Here's another example, would be, say temperature 1 was 100, temperature 2 would be 499, because 5x minus 1 of that is that. Plug that in, 100 minus 5, 100 minus 1. Well, that's all absolute value. This is 499. 100 minus 499 is f of x is equal to 399. So the function is the absolute value of -3 minus 5x minus 1, that's in parentheses, and that's all absolute value equals the temperature difference. Number 5, this is the graph. It has a x-intercept of 0.25 and a y-intercept of 1. As you can see, it is a absolute value graph, so all numbers are positive. There's the graph right there. Right here you can see 100, 399. So on this, here is 100, which is x, and then the function of time difference, which is also equal to y, is 399. So x going, the x-axis is temperature 1, and then the y-axis is the temperature difference. Here's going to be my graph of the function f of x is the absolute value of x minus, in parentheses, 5x minus 1. As you can see, the x-intercept is still 0.25 and the y-intercept is 1. And as you can see here, it goes right 1 and up 4. That's going to be helpful in the next problem. And the y. Okay, number 6 asks for the input of the function when the output is 45. So the function is x minus 5x minus 1. Absolute value equals the function of x. And so we know the output's always going to be y, so it's going to equal 45, which is equal to that. So to solve this, you're going to distribute. So it's going to be negative 5x plus 1. X minus that is going to be negative 4x plus 1, and that's why I showed the equation goes over 1 and up 4, and then the y-intercept is 1. So it's going to equal 45. Subtract 1 from both sides. 44 equals negative 4x. Divide by 4, divide by 4. And x equals negative 11.